The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, guys. So we're going to be solving this very problem. It has two in one. So we're going to find the cosine series and we're going to find the sine series. To find the cosine series, we're going to be treating this as an even function. So this will be an even extension. So all we have to do is to find a naught. So the a part of this, we're going to get started by finding a naught. So a naught is 2 over pi, integral from 0 to pi of f of x dx. So that's what a naught would be. So this will then become 2 over pi. Now, the integral, if you notice, there's no 0 to pi. Instead, it's broken out into 2. We have 0 to pi over 2 and pi over 2 to what? To pi. Sorry, this will be the t because the function is with respect to t. And the problem is, this 0 here is kind of nothing. When the function is 0, there's no need for us to take it because if you integrate 0, it's useless. So the integral of this 0 will go away. Instead, let's take our integral from pi over 2 to pi. That's where we have something reasonable. So this will be pi over 2 down to pi. I think we'll be getting around 1 as our answer. So this is what we're going to be, this is what we're going to have. Of 1 dt. Good. So this will become 2 over pi. Now, if you integrate 1, you basically get x. You basically get x. Then this will be pi over 2 to pi. So this will become 2 over pi. Then x here. Anywhere you see x, you put pi. So this is pi. Minus when you see x again, you put pi over 2. So right now, this will be 2 over pi into pi minus pi over 2 is pi over 2. So when you check this out, some parts we cancel, pi we cancel pi, 2 we cancel that 2. So this is just 1. So that's our a naught. That's a naught. Now a sub n would then become 2 over pi, integral from 0 to pi, f of x cos nx dx. So that's a sub n. So this will be 2 over pi. Then we have the integral. Again, remember that 0 to pi over 2 is nothing. So we're going to throw it away. We're going to only use this 1. And the 1 here is from pi over 2 to pi. So this is pi over 2 to pi. Now f of t was 1. So this will be 1 cos nt dt. All right. Now this will become 2 over pi. Now 1 times anything is that same thing. So we're just going to be integrating cos nt. Now the integral of cos is sine. So this will be sine nt over, when you differentiate this nt, you will get n. So you need to divide by n. And this is from pi over 2 to pi. So this is 2 over pi. The n is a constant, so I can bring it out. So this is n pi. Then we have sine nt from pi over 2 to pi. All right, now this is 2 over n pi. Then we have, anywhere I see t, I'm going to put pi. So this will be sine n pi minus sine n pi over 2. So this is what I have. Now sine n pi has a special value. That special value is 0. Sine n pi will give us 0. Now, since we have only this left, this minus can come outside. So this is minus 2 over n pi sine n pi over 2. Now, there's a particular way that this sine n pi over 2 behaves. So when n is even, sine n pi over 2 is always equal to 0. Then when n is odd, such that we have 1, 5, 9, sine n pi over 2 is equal to 1. Then when we have n equal 3, 7, 11, sine n pi over 2 is equal to minus 1. So that's what we have. Now from this point, some students prefer to now find their A1, A2, A3, A4 because this is looking weird. It's looking weird. But for me, I am not going to do that. I'm going to just leave it like this. So f of x, do I do that sometimes? I do that sometimes. So f of x is a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx. Now our a naught is 1. So this is 1 over 2 plus the sum from n equal to 1 to infinity. A sub n is this value here. So that's minus 2 over n pi sine n pi over 2, then cos nx. Cos nx. Now we can factorize this. So we can say, let the minus 2 over pi come outside. So this will become 1 over 2 minus 2 over pi. Since the minus 2 over pi is a constant, then the sum from n equal to 1 to infinity. What will be left here is, we're going to say times 1. So this is 1 over n. Because the minus 2 is gone, the pi is gone. So what's remaining here is n. Sine n pi over 2 cos nx. So this is what we have. Now this point, this is actually your answer. Yeah, in terms of n, this is just your answer. But we can go forward. We could have 1 over 2 minus 2 over pi. Then let us expand this. So when n is 1, I want to start from this one. When n is 1, this is 1. So we have 1 here times 1 cos 1x. So this will just be cos x. That will just be cos x. Then next, when n is 2, whenever it's even is 0. So let's go to 3. When n is 3, we get minus 1. So this is 1 over 3 times minus 1. So that's minus 1 over 3 cos 3x, because n is 3. Let's go to 4. Now when n is 4, that's even. So this will give us 0. So we'll go to 5. So when n is 5, this is 5 here. And this is positive. So this will be plus 1 over 5 cos 5x. Now the next is 7. The next is 7. So when n is 7, we get minus 1. So this will be minus 1 over 7 cos 7x. And if you notice, there's now a pattern to it. There's now a pattern. So you can say plus 1 over 9 cos 9x minus 1 over 11 cos 11x, just like that. But you can't really get on to infinity. So this will be the answer to the problem. And with this, we've gotten the Fourier cosine series, or what we call the even extension. So now let us find the sine series. This is the cosine series. Let us find the sine series. Now, when we're dealing with the sine series, we only need to find b sub n. We only need to find b sub n. So the sine series is like treating the function as an odd function. So b sub n is 2 over pi, integral from 0 to pi, f of t sine nt dt. So this is in terms of t. Now again, I have to break my 0 to pi to 0 to pi over 2 and then pi over 2 to pi. But if I should do that one over this first interval, the function is 0. So there's no need, because when I integrate within this interval, since the function is 0, it's kind of useless. So I only need to be doing this one. So this will be 2 over pi, and I have the integral from pi over 2 to pi. The function is 1, and then sine nt dt. That's what I have. Now, 1 times anything is that same thing. So I really should not stress myself. So this is 2 over pi. Then I'm going to be having, if I integrate sine, I'm going to get minus cos. So this is minus cos nt over, when you differentiate this nt, you will get n. So you have to divide by that very n. And this is from pi over 2 to pi. Okay. So let me see. So bring out this. Should I bring out the minus? Okay, let's bring out the minus. It doesn't change anything. So bring out the minus, bring out the over n. So this will be 2 minus 2 over n pi. Then we have cos nt from pi over 2 to pi. Next, anywhere I see t, I'm going to be putting these intervals. So this will be minus 2 over n pi, and then we have cos of n pi minus cos of n pi over 2. So this is what we have. All right. This is funny. Okay, so this is minus 2 over n pi. Now, cos n pi has a special value. That special value is minus 1 to the power of n. Then this guy you see here, very funny guy, cos n pi over 2. So that's a very funny guy. So I kind of think, let me write the behavior of cos n pi over 2. So when n is odd, cos n pi over 2 would always give you 0 when n is odd. Next, when n is in the form 2, 6, 10, cos n pi over 2 is minus 1. Then when it's of the form 4, 8, 12, cos n pi over 2 is 1. So this is what we have. So this is the behavior of this guy. That's the behavior of this human being you see here. That's the behavior. Okay. So I think, let me see. I can actually leave my answer like this, or I decide to find B1. So let me do that. Let me do that in this case. Let me find B1, B2, B3, just like that. So this is Bn. Let me find B1. So B1 is minus 2 over, this will now become 1 pi, so that's just pi. And then into minus 1 to the power of 1 is still minus 1. Then when n is 1, that's an odd number. So this will be minus 0. Now that means what I have in the brackets here is just minus 1, because 0 is nothing. So this is minus 1. Minus 2 times minus 1 is plus 2. So this will just be 2 over pi. Next is B2. So let's find B2. So this will be minus 2 over 2 pi into, now if you should put your 2 here, minus 1 raised to the power of 2 will give us 1. Because that's minus 1 squared, which is 1. Minus, when you put 2 here, this will give you minus 1. So we have a minus 1. All right. Now look at this. Minus minus is plus. So 1 plus 1 is 2. 1 plus 1 is 2. So this will be minus 2 over 2 pi times 2. So this will cancel out this. So what we'll be having will become minus 2 over pi. That's what we're going to be having. Next, B3. So for B3, this will be minus 2 over 3 pi into, if you should put 3 here, minus 1 raised to the power of 3 is still minus 1. And then minus this guy here, when n is odd, because 3 is odd, you'll be getting 0. Now, this whole item here is minus 1 because the 0 is nothing. So this is minus 1. Minus 1 times minus 2 will give us plus 2. So that means we're going to be having this as plus 2 over 3 pi. So this is what we have. Next is B4. So for B4, we have minus 2 over 4 pi, because n is 4. And then minus 1 raised to the power of 4 is 1. Minus, now when n is 4, this is 1. When n is 4, that's 1. So this will be 1. And then 1 minus 1 is 0. So 0 times this is 0. Let's go to B5. So for B5, we're going to have minus 2 over 5 pi. And then this will be minus 1 to the power of 5 is minus 1. And then minus, when it's 5, is 0. So this will then become minus times minus will give me plus. So this will just be 2 over 5 pi. You can't really get on to infinity, so this should be enough for your Fourier series. So let us get our final answer. So the Fourier series for a sine series, or the formula would be n equal to 1 to infinity, b sub n sine nx. That's what it's going to be. That's our f of x. Now this will become this b sub n here. You can decide to put this value. Yes, you can decide to put this very value and nothing will be wrong. So I want to do that first. So the sum from n equal to 1 to infinity. Now b sub n is minus 2 over n pi. Then we have minus 1 to the power of n minus cos n pi over 2 sine nx. So this is what your Fourier series will be looking like in terms of n. But the minus 2, this minus 2 here is a constant. The over pi is still a constant, so you can bring it out. So this is minus 2 over pi. Then the sum from n equal to 1 to infinity. What will now be left to be 1 over n. Then we have minus 1 to the power of n minus cos n pi over 2 sine nx. So if they say in terms of, wait, this is t now. Oh, sorry, this is f of t. F of t. So this is f of t. So this will be t. This is f of t. So this will be t. So right now, this here is our Fourier series. These are Fourier series. But also remember that this expression that I have here, you can then expand it. So using this expression here, so this is f of t is equal the summation from n equal to 1 to infinity of b sub n sine nt. Now, since we have different values for b sub n, and we are summing from n equal to 1, meaning we're going to have b1 sine 1t, so that's sine t, plus the next one will be b2 sine 2t, the next one will be b3 sine 3t. We're putting n as numbers. The next one will be b4 sine 4t. Next one will be b5 sine 5t, and just like that. We can't really get on to infinity. I want to wipe this part out. So now, let's put in our b1. So b1 is 2 over pi. So this will be 2 over pi sine t. Next one, b2. b2 is minus 2 over pi. So this is minus 2 over pi sine 2t. b3 will be 2 over 3 pi sine 3t. b4 is 0. So this one is gone. Then b5 is 2 over 5 pi. So this is plus 2 over 5 pi sine 5t. Just like that. Though you can factorize because 1 over pi is common. In fact, not just 1 over pi, 2 over pi is common. Yeah, 2 over pi is common. So this will be 2 over pi into, when you remove all of the 2 over pi, this will be sine t minus sine 2t plus 1 over 3 sine 3t plus 2 over, sorry, the 2 is out. So this will be 1 over 5 sine 5t, just like that. Okay, so this is what you have. This is what you have. That's looking kind of weird, but it's fine. So this will be the answer to our problem. I'll see you in the next video. Thanks for watching. Bye.